Okay, so with exponent properties, basically the rules we know. We know how to add, we know how to multiply, we know how to divide. So all they do is we're trying to do it what I describe it as a separate language. So it's kind of like we're doing the same thing. We're still forming sentences in math, just with different rule set. But we're doing math the same way. The first thing is when you multiply two numbers together, like x to the third times x to the fifth, you add the exponents. So x to the third times x to the fifth is x to the 3 plus 5, which is the x to the 8. Good. Now, if it's x, it would just stay x. What if it's a number? Let's say like 4 to the second times 4 to the third.
You leave the base.
You still leave the base. This is very important. Don't trick yourself. 4 to the second times 4 to the third will simply be 4 to the fifth power. The base stays the same. The only thing that's interacting is the exponent.
But if they're different,
Wait, isn't this the review? Like here?
Different, you couldn't combine the exponents. We'll talk about that soon.
no, it's the study. What? I thought you multiplied the two numbers.
If they're the same, you only add the exponents. But your question is, what if they're different things? I'll get your question after I finish it. So for example, if it's 3 to the second times 4 to the third, in this case, 3 and 4 cannot interact because 3 is different than 4. So what we're going to do is just find the math. We do 3 times 3, which is 9, and times that to 4 times 4 times 4, which is 64. You just typed that in your calculator. 4 times 4 times 4 is 64.
We didn't do it that way.
Well, pay attention. You made me learn. So then 9 times
Is this
64.
Is this 6 because you put an invisible 1 on the 9? So you add the 3, 2, and 5 and 1.
Why is it 6? There's no 6 on the board. It's 9. Because it's 3 times 3.
Bad question.
But isn't that adding 3 plus 2 plus 1?
I don't know what you're doing. That's factorial. So you're like 5 months ahead. Don't leave that behind. So that's 9 times 64. 9 times 64. Anyone knows that off the top of their head, by the way?
No.
I guess not. It's
It's a
probably
big number.
5, I don't know, 86 maybe? I don't know.
I have a question. So if your whole
That's wrong. That's 5
if
seventy.
your like big numbers are the same, you add the exponents. If they're not the same, you multiply. Like
You have to do the number first, then multiply. All right. What's up? I'm sorry. You had a question up earlier. Go ahead. No, not that. You sure? Okay, Shane.
Okay, can I just do 20 to the fifth power and install that?
20 to the fifth power?
That's what, 12.
No, you cannot combine the insides like that. You are not allowed to combine the insides like that. That's why I told you, multiply them out first, then combine them. Yes?
9 times 64 is 576.
I miscounted by 10.
Here, like this one.
Thank you, Doc. It was, I think I did say that.
Yeah.
No, I appreciate it, though.
I think I did.
What do you, whoa, I want to focus on my stuff.
It's about this.
What?
Don't you multiply those numbers?
Well, those are just 6, like those are normal numbers. They don't have exponents, so we don't have to follow that rule.
That has an exponent.
Not the 6 or nor the -3. The x's have exponents, but not the numbers. So this is the question I was just asked. What happens when they're mixed? Like 6x to the third times 4x to the 7. In this case, normal numbers multiply normally. You're going to hear me say that a lot. So 6 times 4 is just 24. And then x to the third, x to the 7, you follow your exponent rules, which is going to be x to the 10.
wait, why didn't you do the one you did with that problem?
Well, 6 doesn't have an exponent, so I don't need to do any math. And 4 does not have an exponent, so I don't have to do any math. They're already normal.
Oh,
They're already-
the x is at the
They're already ready to be multiplied. You think of it like that. They're already primed to be multiplied.
Do
Okay.
you write that x and 3 in like parentheses?
Like this.
No, like for the other one, you could just write the 6 in a parenthesis and the x. Yeah, like
It will be written like I had it before, without parentheses. You gotta know those are different, okay? All right. So when you multiply two bases, you add the exponents. In this case,
Can you go back?
sure. The next thing we're gonna go over
Wait,
is
what's the test?
Thursday. But
No, wait, not this.
yeah, next week Thursday. But remember, we have tomorrow. Monday we're off. Tuesday. Wednesday I believe is another
Monday
seed.
we're off?
We just have Monday off.
Thank you.
President's Day.
President's Day.
President's Day. Yeah.
Oh, for real?
Yeah, we have Monday. Hey, look at that! You just got a 3-day weekend. You didn't even realize.
Best feeling.
Tuesday, we have class, but then Wednesday might be another seed. So the last time we might
No.
meet is Tuesday. Then Thursday will be our test. That's why I'm starting now.
Let's do over test, okay.
Next one.
So can we take it on Friday?
Just Brandon told me.
Brandon Total.
And I'll try to post it on the Google
How
Classroom.
many
No, I
subscribers
want
do you
to
have?
get it over with.
I don't know anymore right now.
You care?
No, I'm not gonna reach the threshold to make money off it. I'm not the next Mr. Beast. I'm just Mr. Tournament. All right. In this case, we add x to the third and x to the fifth. So x to the third, x to the fifth. You're going to multiply the exponents. So that's going to be x to the 15. So when you have an exponent on an exponent, you multiply them. Now that works also with normal numbers. 3 to the second to the, let's do to the second power. In that case, that's 3 to the second power. 2
Nine.
times 2, 3 to the fourth power.
Wait, why don't you do 2?
Very important. You deal with exponents first before you do any numbers. You deal with exponents first before you
Wait,
do any
I
numbers.
thought you multiply. Oh, never mind.
No. You cannot affect it like that.
Wait, I thought you do 3 to the second power.
You could do, there's 2 routes you could do this. 3 to the fourth power, which is 3 times 3 times 3 times 3, 81. Another way you could technically do it, if you had the same question, just to show, you could technically do it where it's 9, you do the number first to the second power. Wait, 9 to the second power, or 9 times 9, is also 81. There are multiple routes. I suggest combine exponents first, then do the math at the end. Otherwise, you might be misstep or you might double something. I've seen it before where you'd like double or something because you do it twice.
Don't you do 3 to the 7th power?
Why 7?
Because you add, like, you bring it like this.
What's 2 times 2?
No,
No, you do not multiply or add the base number. Does not matter. Same way X does not change.
How do you know if you multiply it? Or, like, how do you know?
It's exponent on exponent. Exponent is affecting the exponent.
But doesn't it, like, go like this?
Yeah, it distributes to the 2 here. Now I'll show you one without a number, so I'll show you what you mean.
So how would you know?
So like 3, x to the second, y to the fourth, let's say to the third power, okay? So we're gonna take these exponents and bring it to this 3, this 2, and this, or this y, and this x and this y. Now, 3, if you don't see a power on it, what's the invisible power on it?
1.
Good, it's gonna be a little 1 right here. So 1 times 3 is 3 to the third power. Now this one, this is to the second power. 3 times 2,
6.
x to the sixth power. And then, this is going to be 4. 3 times 4, y to the 12th power. Okay?
Don't you solve the 3 to the 3rd power?
You do solve 3 to the third power, which is 3 times 3 times 3.
9 times 3 is 27.
Good, so 27, x to the 6th, y to the 12th.
So how do you know which one to do? How do you
don't-
know if you add it to the whole number or just that one?
When I have an exponent on the outside of a big parentheses like this, I know I'm bringing it to everybody. It's not like the same base. Go
How
ahead.
did you get 27?
3 times 3 is 9, and then another 3 is 27. I just did 3 times 3 times 3.
Okay.
All right. Next rule we learned is that division is subtraction. So x to the 10 divided by x to the third, that means this is going to be x to the 7. Okay? Because that's x to the 7, we know that when we divide, we subtract. That also works for normal numbers. 3 to the 10th power divided by 3 to the 7th power, you divide the exponents only, which means you subtract the exponents. You do not change the actual number. So this is 3 to the
10
third.
minus 7.
Yep, 10 minus 7,
That's
which is
like a
3.
huge problem that like on
They
the
should be nothing more than, let's say 5 squared. I'm not gonna make
But see, this
something.
one's
Or 5
5 to
cubed.
the 12th power. Because I don't even know how to
That's
do
so huge, I would not give you something like that. Okay?
Mr. Trouble?
Yeah?
I did it, and I thought I understood it, but I did it myself, and I got a different answer when I put it in the calculator.
Then let me finish my review, and then I'll go over particular questions. Okay?
Okay.
All right. Now, division. There's a couple of things you need to know about division. First off, you'll be given as fractions sometimes. So, for example, if I'm given something like this, let's do variables to be less confusing. So let's do like x to the 8th power times 1 over x to the second power. In this situation, you're like, wait a second, one's a fraction, one's a normal number. That's kind of weird. Well, I can make anything a fraction. How do I make anything a fraction? By what number? You could always put it over 1. So let me put this over 1.
Oh yeah.
And when you multiply, you go straight through. So 8x or 8x to the 8 times 1
Wait,
is...
it's not 8x.
You're right. It's x to the 8 times 1 is x to the 8 over x to the second,
2.
x to the second. Yeah. So now, oh, this is obvious. Now I just subtract. 8 minus 2,
Oh no.
6.
Oh. Yeah.
Are you gonna give us like big problems? Like on the top, there's gonna be like
Not huge numbers, hopefully.
like
This
12
is
times
this is the
12
textbook.
over 12.
So this is the textbook. They'll give you huge numbers. On my test, it won't be huge numbers.
Okay.
So this one, let's say you had this situation. So let's do a combo. Let's say a to the third, b to the second, over c to the seventh, to the second power. Okay? In this case, this second power is going to be given to the a, to the b, and to the c. So everyone gets a little bit of the 2. Now it's an exponent to exponent. That means we're going to multiply them. So that's going to be 8,
6.
good, b to the 4 over c to the 14. Now, is any of these letters the same?
No.
No, so they cannot interact with each other. So you are done here. They cannot interact with each other.
What if they're the same letters?
Let's do one with the same letters. So let's say you had a to the third, b to the 7, over a to the 6, b to the 2. And let's take that to the whole power of 3.
So A is 6. No, it's not.
So,
It's 9.
there are 2 roots for this. Please pay attention. There's 2 ways to do it. You could distribute first, then subtract after, or you could subtract first and then distribute after. I'm going to show you both.
Wait, can you scroll up to the big problem? A little. Yeah. This is like too complicated.
Okay. So the first row I'm going to do is distribute first, then subtract.
Okay.
So in this case, I'm going to take this 3, bring it to here, 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 and here. Which
A
means
is 9.
A 9, B 7 times 3 is 21, over A 6 times 3 is 18, B 2 times 3 is 6. B is 6.
Oh, but they're the same letter.
Yeah, so now I have to subtract each one. So 9 minus 18, what is that? That's actually going to be a to the negative 9. And 21 minus 6 is going to be b to the 15. Now we have another rule that's being shown here. When we have a negative exponent, we don't like that. Kind of like it's a grammar situation. We don't like that in math. It's kind of like improper. It's true, but it's improper. So what we're going to do is any negative exponents, we're going to move to the bottom, assuming it's on the top. If it's on the top, on the bottom already, it will move to the top. So only a will move to the bottom because only a is the negative exponent.
Oh.
So your final answer here is b15 over a9.
Oh,
Okay?
So what do you mean when you say moving A to
what
the
does that
bottom?
mean?
So because a is a negative exponent, we don't like that as a negative exponent. In order to remedy that, we move it to the bottom, aka the denominator of a fraction.
So I just switch it. I just say it's.
You move to the bottom and switch the sign, yes. Moving it to the bottom does switch the sign. It's not mathematically doing anything. You're not adding or subtracting. It's very easy, but people forget that, or sometimes they just switch it without moving it, or they move it without switching it. It's an awkward situation. Okay. Now, I said there was 2 ways to do this problem, so I'm going to rewrite this problem. So it's going to be, well, this is for the first version. So it's a to the third, b to the 7, to the third power, b to the 6, or a to the 6, b to the 2. In this situation, what I could do is subtract first, so simplify what's in the parentheses first, then distribute. So let's do that. I'm going to subtract first. So I'm going to get a is -3 and b is 5. The parentheses are still there because I couldn't take care of it yet, or I did not take care of it yet. So a to the -3, b to the 5. So I subtract first this time. From there, I'm going to distribute the 3. So sometimes this is nicer because you're doing less distribution. So that's going to be -3 times 3 is -9. And b 5 times 3 is b to the 15. Remember, same issue as before. We have a -a. We don't like that. So we're going to change it. So it's going to be b 15 over a to the 9.
I got lost on the
Is this practice for homework?
It is not homework. It's not required homework. It's just practice readings. On the top right says the questions I would recommend. I will post it later, but at this time I'm not. And again, it won't be posted in the homework column. It'll be posted, I guess, in status or whatever that column is called in Google. The stream. All right, we kind of already talked about this. So negative exponents, so like x to the -5, we rewrite that as 1 over x to the 5. So we bring it down to become positive. There's also the reverse situation. Let's say it was on the bottom already. So let me do it like this actually. Let's do y to the -3 over x to the -4. In this case, the y to the -3 is negative, so I'm going to move that down. But the x to the -4 is also negative. It's not happy on the bottom, so it's going to move on top, which means this is going to look like x to the 4 over y to the 3. So when you have a negative exponent, it flips. And something that I told you today, anything to the 0 power will equal 1. So even if I had something crazy like this, I don't know, 6x to the 3rd, y to the 7, a to the 11, all to the power of 0, we don't need to distribute. As soon as I see it's the power to 0, I write my answer as 1.
Will you give us a problem like that on the test?
Maybe.
So you don't know it, just.
No, he's gonna do like some sort of crazy number. He's gonna do.
Maybe. Who knows?
Now how would
I
you
know.
What if it's the power of 1?
It's
Yes,
okay.
anything that's
We
better
should
than
make
1.
that question
There's
50
a
points.
question like number 7.
This is total.
7 of this?
Yeah.
So we'll make that
On what
question
section?
50 points. So that if someone messes it up, they fail.
The
So-
first one.
Okay. 7.3 or 7.1? Okay.
What?
I'm sorry, what's up? Alright.
Is it raining?
No.
No.
I don't think no.
One, I just want to make sure we practice every version. So let's say if I had this situation, 4, x to the 3, y to the -5, to the -2 power. In this situation, I'm going to distribute this -2 to the 4, to the 3, and to the -5.
What?
4 to the -2 power.
What is that? Is it 0?
It's a 2, my bad, a -2.
No. Oh, that. Oh.
X to the -6, this is a -2. And y, -5 times -2, that's a double negative, so it becomes positive 10. This 4 to the -2 power, we're going to move down. This x to the -6 power, we're going to move down. This y to the 10 power, we're going to keep. It's no negative, it's no problem. I'm going to write it over here. So over here. So it's going to be y to the 10 over 4 to the 2nd power, x to the 6th power. I I like numbers to actually be done out. 4 times 4 is 16. So I'm going to rewrite my final answer. Y to the 10, 16, x to the 6. Only deal with the numbers after you make it positive. Don't do it then with a negative exponent. Otherwise, you're going to get slipped up, okay? That should cover every skill that you need to do in the test. Of course, it could get a little bit weird because you can combine them, but that's for your review packet to practice, plus your old notes to practice, okay?
Okay.
All right, I'm going to end the recording. I'll take particular questions.
Keep going.
No.